Hi, welcome to this complete walkthrough of Edexcel A-Level Pure Mathematics Paper 1 of June 2018. It will be a very good idea for students to practice with the past papers starting from June 2018, as Edexcel had changed the specifications very extensively from the teaching years of 2017. In this walkthrough, I shall take efforts to make the same intensity of presentation as the students are expected to do in the actual exam. This is a paper carrying 100 marks and is of length 2 hours. So we will attempt to finish it within the time allotted. Okay, let's jump to the first question. Given that theta is small and is measured in radians, use the small angle approximation to find an approximate value of 1 minus cos 4 theta over 2 theta sine 3 theta. So from the radians chapter, you would have seen there are 3 rules for angle approximations when theta is in radians and is close to 0. Theta is small means theta is close to 0. So those 3 rules are, it will be given in your formula sheet. So anyway, let me write it here. Sine theta is equal to theta, tan theta is equal to theta, and cos theta is equal to 1 minus theta square over 2. So these 3 rules are super important to remember. So what we are going to do here is we will apply these into this. So this is equal to 1 minus, there is a minus sign here, so it will be better to open a bracket because that minus sign will play havoc. So 1 minus, instead of theta, to write this theta square, I'm going to write 4 theta square over 2 over 2 theta times sine 3 theta will become 3 theta. Simplifying this, we get 1 minus 1 plus 16 theta square over 2 over 2 theta times 3 theta is 6 theta square, which will simplify to 1 minus 1 cancelled out. So 16 theta square over this 2 comes to the denominator as 12 theta square, therefore that is equal to 16 over 12, which is 4 over 3, which simplifies to 1 over 3. Here I would request students to watch out for this. A very common student error is writing out this 4 theta square over 2 and then square it. Therefore, the 2 will also be included in the square unwittingly by the students. So please watch out. This 2 does not form part of the square. Question 2. A curve C has equation y equals x square minus 2x minus 24 square root of x where x is greater than 0. Find dy by dx and d square y by dx square. So looking at this equation, you can see that this is written in indices except the last one. So in order to start differentiating it, it will be better if we write it as y is equal to x square minus 2x minus 24 x to the power of half. Okay, now differentiating this, we get dy by dx is equal to 2x minus 2 minus 24 times half is 12, x to the power of half minus 1 is minus half. So I had differentiated this again to find d square y by dx square. So 2, then minus 12 times minus half is 6, x to the power of minus 3 over 2. Question B. Verify that C has a stationary point when x is equal to 4. This means if I put x is equal to 4 in dy by dx, it should give me a value of 0 if it is a stationary point. So if it gives 0, we are good. That's what we need to show here. Question B. Let's say putting at x is equal to 4, okay, dy by dx equals 2 bracket 4 minus 2 minus 12 4 to the power of minus half. Let's see whether this simplifies to 0. This is 8 minus 2 minus 12 times 12 over square root of 4 in the denominator, which is 2 here, which means 8 minus 2 minus 6, which is equal to 0. Therefore, At x is equal to 4, there is a stationary point. At x is equal to 4, C has a stationary point. Part C. Determine the nature of the stationary point, giving a reason for your answer. So we have the d square y by dx square function here. If we put x is equal to 4, depending on whether it is positive or negative, we can determine the nature of the turning point. So let's put x is equal to 4 in the second derivative. That is C. At x is equal to 4, d square y by dx square equals 2 plus 6 bracket 4 to the power of minus 3 over 2, which is equal to 2 plus 6 times this 4 to the power of minus 3 over 2 is 6 over 4 to the power of 3 over 2, which is actually 2 plus 6 over this 4 to the power of half is square root of 4. So this is 2 to the power of 3, which means 2 plus 6 over 8. Okay, that is 16 plus 6, 22 over 8. And this is positive. As d square y by dx square is greater than 0, it's a minimum point. Question 3. Figure 1 shows a sector AOB of a circle with center O and radius r centimeters. The angle AOB is theta radians. The area of the sector is 11 centimeters square. Given that the perimeter of the sector is 4 times the length of the arc AB, this is an important information for us, find the exact value of r. If theta is measured in radians for a sector, there are two formulae which are quite useful for us. One is for the area. Area is equal to half r square theta, and then arc length is equal to r times theta. So we can use this formula in this question. Area of the sector is 11 centimeters square. So let's write half r square theta is equal to 11. So what's the next equation? Given that the perimeter of the sector is 4 times the length of arc AB. All right. So perimeter is equal to, you can see from the sector, there are 2 radii there, plus there is an arc length, right? That is equal to 2r plus r theta. So this perimeter is 4 times the length of the arc. That means we can say 2r plus r theta on one side is equal to 4 times r theta on the other. So the strategy for this question is, from this equation, we can find the value of theta, and then putting that into the area equation, which is equal to 11, we will be able to find the value of r. So here, let's factorize the r out. So r bracket 2 plus theta is equal to 4 r theta. And in the next step, we'll divide both sides by r. So we get 2 plus theta is equal to 4 theta. So this equation is independent of r. So we can easily find out theta from here. So 2 is equal to 4 theta minus 1 theta is 3 theta. Therefore, theta is equal to 2/3 radians. Okay. So now putting that back into our area equation, we know that half r square theta is equal to 11. That means half r square times 2/3 is equal to 11. Okay, that means 4 over 6 r square is equal to 11. So r square is equal to 11 times 6 over 4, which is 66 over 4. So this is actually 2 over 6. 2 over 6 r square is equal to 11. Therefore, r square is equal to 11 times 6 over 2, which is 66 over 2. So further simplifying, we can get r equals square root of 66 over 2, which is square root of 33. No need of writing plus or minus because radius can only be positive. Question 4. The curve with equation y equals 2 ln 8 minus x meets the line y is equal to x at a single point x is equal to alpha. Show that alpha is between 3 and 4. So the method for this question would be, since these two curves, that is the curve and the line, have an intersection point, therefore we can put that equal to each other and then derive a combined equation for the function. And in that function, if we put x is equal to 3 as well as x is equal to 4, it should be giving us a sign change, and that should be enough for us to conclude that the alpha is between 3 and 4. So let's write the two equations. So let's write at intersection point, the equation for the curve is 2 ln 8 minus x, and the other one is y is equal to x, that is x. So in order to combine this, let's bring them together. So 2 ln 8 minus x is equal to 0. So this is the new function of x. Okay, so you can write f of 3 is equal to 2 ln 8 minus 3 is equal to 2 ln 5 minus 3. Putting that into the calculator, I get 0.22. Now let's write f of 4. That is equal to 2 ln 8 minus 4 minus 3. That is equal to 2 ln 4 minus 3. 2 ln 4. Okay, so here it should be 4, isn't it? Because x is equal to 4 there. So 2 ln 4 minus 4. Putting that into the calculator again, this time it's giving me minus 1.227. Now we need to conclude by saying, as there is a sign change between f of 3 and f of 4, and as the function is continuous, there is a root between them, alpha lies between 3 and 4. Or we can also write alpha lies in the interval 3, 4. Okay. Next part of the question. A student uses the iteration formula xn plus 1 equals 2 ln 8 minus xn in an attempt to find an approximation for alpha. So this one is the same as what we derived earlier. X is equal to 2 ln 8 minus x. So this forms the combined function of x now. Using the graph and starting with x1 equals 4, determine whether or not this iteration formula can be used to find an approximation for alpha, justifying your answer. So looking at this diagram, suppose we start with x1 is equal to 4. We need to actually show graphically using our numerical methods to show that it will converge to this root. So what we need to do is start with a line going up from 4, okay, and meeting the curve here. Then from that point, extend a line to meet the line, y is equal to x. From there, again, draw a line to meet the curve. So repeatedly, if you go like this, from the curve again to the line, and from the line again to the curve, and from the curve again to the line, so you can see that it actually converges. This is called a CAIIB diagram. And if it is spiraling inwards, it means that x is equal to 4 is a valid assumption to start with, and we will be able to reach the root. So that's what we have to write in one sentence. B. We can say, as the CAIIB. To get marks for this question, we need to show that the CAIIB actually converges. So spirals inwards, this iteration starting with x is equal to 4, let's say x1 is equal to 4, can be used to locate the root. Okay, fine. Question 5. Given that y equals 3 sine theta over 2 sine theta plus 2 cos theta, where theta is between these values in the domain, show that dy by d theta is equal to a over 1 plus sine 2 theta, where a is a rational constant to be found. Okay, so we need to differentiate a fractional expression here. So you need to use what? The quotient rule. So where this will be the u and these two together will become the v. So what's the formula? Dy by dx is equal to vu dash minus uv dash over v square. So let's plug those values into this equation. So this is what? Okay, so dy by dx is equal to, okay, so always remember we cannot interchange the numerator. We should start with v and then differentiate u. So what's the v? 2 sine theta plus 2 cos theta times differential of 3 sine theta is 3 cos theta, okay, minus, now we write 3 sine theta times v dash. V dash contains two terms, therefore 2 cos theta minus 2 sine theta. And in the denominator, let's put a long denominator line here. Okay, so it's going to be v square, which is 2 sine theta plus 2 cos theta square. So expanding this, so this will be dy by d theta. This is not dx, this is d theta. So dy by d theta is equal to 3 cos theta times 2 sine theta is 6 sine theta cos theta, okay, plus 3 times 2, 6 cos square theta, minus 3 sine theta times 2 cos theta is 6 sine theta cos theta, minus times minus plus 6 sine square theta, again divided by, okay, we can expand the denominator too. So this is going to be 4 sine square theta plus 3 times 2 times 2. So 2 times 2, 4, 4 times 2 is 8 sine theta cos theta in the middle term. And final term will be square of 2 cos theta is 4 cos square theta. All right. Now dy by d theta again. Let's cancel out whatever is possible. This 6 sine theta cos theta cancels off with this minus 6 sine theta cos theta. Then we have 6 cos square theta plus 6 sine square theta. So going by the identities, cos sine square theta plus cos square theta is equal to 1. So it's going to give us 6 in the numerator. Okay, in the denominator we have 4 cos sine square theta plus 4 cos square theta, which will be 4 bracket sine square theta plus cos square theta, which is equal to 4, plus we have 8 sine theta cos theta. Okay, so now this is equal to 6 over 4 plus. Let's look at this closely. So this is actually an expansion of sine 2 theta. You know that sine 2 theta is equal to the double angle expansion 2 sine theta cos theta. Okay, so 1 sine 2 theta will be giving us 2 lots of sine theta cos theta. So if there are 8 lots of sine theta cos theta, it means it will be how many lots of sine 2 theta? 4 lots of sine 2 theta. Okay, so that is the correct answer. Now let's look at whether there is any manipulation required as per the question. So what does it say? A over 1 plus sine 2 theta. So we need to do a little bit of simplification here. All right, so 6, 4 and 4 are all multiples of 2. So we can straight away divide everything by 2. So we can write 3 over 2 plus 2 sine 2 theta. So we are still not there. So we need to write this as 3 over, take the 2 out, after factorizing. So 1 plus sine 2 theta. Okay, so we are nearly there. So we can write this is 3 over 2 times 1 over 1 plus sine 2 theta. That's it. So this 3 over 2 is essentially the capital A, which is represented in the question. So we could as well write it here. A is equal to 3 over 2. Question 6. The circle C has center A with coordinates 7, 5. So let's write this as 7, 5. Line L with equation y is equal to 2x plus 1 is a tangent to C at point P. So this is y is equal to 2x plus 1. And it is tangent at point P. Show that an equation of the line PA is 2y plus x is equal to 17. So equation of PA means equation of this radius. Okay. So you know that tangent is perpendicular to the radius. Therefore, starting from the gradient of this tangent line, we can find the gradient of PA. And therefore, we can find the equation of PA because it's passing through the point 7, 5. So that's our strategy. So let's write equation of the line as line L is y is equal to 2x plus 1. Therefore, L gradient is equal to 2. Then you write as PA is perpendicular to L, PAM, that is gradient of PA is equal to the negative reciprocal of 2, that is minus 1 over 2. Then you write at 0.75 through which this PA passes, we can say 5 is equal to mx, that is minus 1 over 2, x is equal to be 7 plus c. So from this we can find out c. So 5 plus 7 over 2 is equal to c, which means 17 over 2 is equal to c. Hence, writing it in the form that is decided here, y is equal to mx plus c. So y is equal to minus half x plus 17 over 2. Let's look back at what the question wants. We need to write 2y plus x is equal to 17. So we need to multiply by 2 so that the denominators can be removed. So 2y is equal to minus x plus 17. So 2y plus x is equal to 17. That's it. B part. Find an equation for C. Here C means the circle. And we know that equation of a circle has got the center and the radius parts to it. So we already know the center. The center is what? 7, 5. Okay. So we only need to know the length of the radius therefore. So we can say that. So if it is 7 and 5, the coordinates for the center, it's going to be x minus 7 square plus y minus 5 square is equal to r square. To find the length of the radius, we can first find out the intersection point of the tangent with the circle. And if you know the intersection point, between center and that point we can work out using the distance formula the actual length. So we have the two equations. One is the tangent is y is equal to 2x plus 1. And equation for PA is equal to y. We already found it out. We can use the y is equal to format. That is y is equal to minus half of x plus 17 over 2. Y equals minus half of x plus 17 over 2. Then we can say at the intersection point 7, 5, they are equal. That means 2x plus 1 is equal to minus half of x plus 17 over 2. Actually, not at 7, 5, at the intersection point P, between the tangent and the radius, 2x plus 1, the equation of the line, is equal to equation of the radius minus half of x plus 17 over 2. So from this we can solve for x, right? So multiply everything by 2. So we get 4x plus 2 is equal to minus x plus 17, which means 3x is equal to 17, take away 2, 15, leading to x is equal to 5. Okay, if x is equal to 5, then we can find out y equals 2x plus 1. So 2 times 5, 10, 10 plus 1, 11. So here we are. We got the coordinates for P. Therefore, P is 5, 11 and center is 7, 5. Alright. Therefore, the distance between them is square root of 7 minus 5 square, that is 2 square, plus 5 minus 11, that is minus 6 square, is equal to square root of 4 plus 36 is equal to square root of 40. Let us relook at what we have done here. 4x plus 2 is equal to minus x plus 17. Okay, so from here it is 5x is equal to 17 minus 2, 15. So x is equal to 3. X is equal to 3 and y is equal to, now I need to change this y also. What will happen if x is equal to 3? X is equal to 3 means 2 times 3, 6 plus 1, 7. So this is 7. So this point is, P is 3, 7 and center is 7, 5. Okay, so we need to rewrite this. Okay, so what happens is 7 minus 3 is 4 square plus 5 minus 7 is minus 2 square, which translates to square root of 16 plus 4 is equal to square root of 20. Therefore, C is x minus 7 square plus y minus the coordinate, y coordinate was 5, wasn't it? So x minus 7 square plus y minus 5 square is equal to square root of 20 square. Or we can also write this as just 20. Next part of the question, the line with equation y equals 2x plus k, where k is not equal to 1, is also a tangent to C. Find the value of the constant k. So let's sketch it out to see what the question wants us to do. So here we have the C part. Okay, so y equals 2x plus k is also a tangent. We already know that y is equal to 2x plus 1 is a tangent. So if I draw the circle here, okay, so this is y is equal to 2x plus 1. Now you can see that the second equation y is equal to 2x plus k is also having the same gradient. Therefore, they should be parallel. If the second line is parallel to the first line, it can only be at the other end of the circle like this. Between them should be the diameter. There is no other way. The two tangents have to be on either side of the diameter, with center being the midpoint. So this point is P. Let's call this point for the second tangent as M, the intersection point, and this point is 5. Is it 7, 5? 7, 5. Okay, and we already determined P as 3, 7. So we can say that this is 3, 7. Okay, so we can write here as the two tangents are parallel to each other, they are on the opposite ends of the diameter. They are on the opposite ends of diameter with center as the midpoint. So let's call this m as x comma y. So from this point P and the center, we will be able to figure out what x and y are. Therefore, 3 add x over 2 is 7, the x coordinate of the center, and then 7 add y over 2 is equal to 5, the y coordinate of the center. So from this we can figure out x is equal to 7 times 2, 14, minus 3. Okay? That is equal to 11. And here y equals 2 times 5, 10, minus 7 is equal to 3. Okay, so therefore m is 11, 3. So how is this going to help us? We can put this into the equation for the second tangent and figure out what k is. So you know the second tangent was y equals 2x plus k. Therefore at m, y equal to 3, x is equal to 11 plus k, which leads to 3 is equal to 22 plus k. Therefore, k is equal to 3 minus 22 is minus 19. Question 7. Given that k belongs to the set of positive integers, show that this integration is independent of k. So in order to show this, we need to integrate and evaluate and show that there is no k in the final result. That's what is meant by independent of k. So let's write this equation. This expression is integral between k and 3k of 2 over 3x minus k dx. Okay, so this is equal to, let's start integrating this. Put the square bracket. Okay, 2 is the coefficient, so nothing happens to it. But 3x minus k is in the denominator with the power of 1. So for integrating such expressions, we have to bring in ln. So that is ln 3x minus k, okay, multiplied by. Now we need to also account for this 3x. When we differentiate 3x, we will be multiplying by 3. So when we do the integration, we need to do the opposite of it. So we need to put 1 over 3 and then put square bracket and put the limits k and 3k. Simplifying this once again before evaluation, we can write this as 2/3 ln 3x minus k modulus between k and 3k. Right, now I think we can evaluate it. So 2/3, so start writing the smaller bracket, 2/3 ln. So wherever x is there, we need to put in 3k. So 3 times 3k is 9k minus 1k. All right, so close the bracket now. Minus new bracket with a 2/3 ln bracket. Instead of x now, I'm going to put k, so it becomes 3k minus 1k, close the bracket. Okay, so simplifying this totally, we have 2/3 ln 9k minus 1k is 8k minus 2/3 ln 3k minus k is 2k. All right, so 2/3 is common, so let's take it out. Ln, we can say 8k over 2k. So now you can see that k cancels out nicely, so it's independent of k. So 2/3 ln 8 over 2 is 4. And then you write this is independent of k. So we have shown that it doesn't have any k. B part, show that integral 2 over 2x minus k to the power of 2 between limits k and 2k is inversely proportional to k. So here again we have to integrate, evaluate, and say that it satisfies the inverse proportional equation. So let's write out the equation once again. So this is integral between k and 2k of 2 over, so this time it is a different denominator, 2x minus k square dx. Okay, so we need to rearrange this before we start integrating, so that it is equal to integral between k and 2k. So 2 bracket 2x minus k to the power of minus 2 dx. Right, now it is integratable, so put square bracket. Okay, so what do you write here? 2 times 2x minus k to the power of minus 2 plus 1 is minus 1 whole divided by minus 1. Again we have to account for this 2x, so we need to multiply by half and between k and 2k. Let's simplify this inside before we evaluate it. Okay, so this 2 and that 2 will cancel. There is a minus sign here, so minus 2x minus k to the power of minus 1 between k and 2k. Now we can evaluate it. So minus, so wherever x is there we are going to put 2k. So bracket 2 times 2k is 4k minus 1k to the power of minus 1, close the bracket, minus, now this time again there is a minus, therefore 2 times k is 2k minus k to the power of minus 1, close the bracket. Okay, so now we need to simplify this. So what does this mean? This is actually minus 4k minus k to the power of minus 1 means minus 3k whole to the power of minus 1. Okay, minus and minus plus, then 2k minus k is 1k to the power of minus 1. This is equal to minus 1 over 3k plus 1 over k. Okay, so now let's make the same denominator for both. So minus 1 over 3k plus, multiply this by 3 and divide also by 3. So we get 3 over 3k. So this will be 3 minus 1, 2 over 3k. So what does this mean? So this is actually 2/3 times 1 over k. So this means this is, the result is inversely proportional to k. So we can say this is inversely proportional to k because k is in the denominator here. Question 8. The depth of water d meters in a harbor on a particular day is modeled by the formula d equals 5 plus 2 sine 30t degrees between, where t is between 0 and 24. So it can be 0 and greater, but should be less than 24. Where t is the number of hours after midnight. A boat enters the harbor at 6:30 a.m. and it takes 2 hours to load its cargo. The boat requires the depth of water to be at least 3.8 meters before it can leave the harbor. Find the depth of the water in the harbor when the boat enters the harbor. Fine. So here we need to just put in the time when the boat entered and then solve for d. So let's write, the question was what? D is equal to 5 plus 2 sine bracket 30t, right? Okay, so now let's put d is equal to 5 plus 2 sine, and in place of t we are now going to put the time. What was the time? 6:30 a.m. So we should be putting 6.5 hours and then putting this into the calculator. I get 4.48 meters. I'll tell you a common student error. It's writing 6.3 here instead of 6.5. Because it's number of hours, we should convert 6:30 a.m. into 6.5 hours after midnight. Find the depth of the water in the harbor when the boat enters the harbor. We did that. Find to the nearest minute the earliest time the boat can leave the harbor. All right. So what we need to do here is the minimum amount of water that's required is 3.8 meters. So let's put that as 3.8 is equal to 5 add 2 sine 30t. So we will now solve for different values of t, and then we will see the earliest time when the boat can leave, right? So this is 3.8 on one side and 5 on the other. So it's minus 1.2 is equal to 2 sine 30t. That means dividing both sides by 2, minus 0.6 is equal to sine 30t, right? Therefore, 30t will be what? Sine inverse of minus 0.6. Okay, that gives me a value of minus 36.87. Now we need to change the interval because we are solving for 30t and not t. Therefore, the question was saying t is greater than or equal to 0 but less than 24. Now we need to rewrite this t as 30t here, and therefore it will be on one side it will still be 0 and on the other it will be 30 times 24, which is equal to 720 degrees, right? 3 24s are 72, right? Now second point to discuss here is never sort out this without drawing the 4-quadrant diagram, because then only we will be able to identify all the angles. So sine of an angle is negative. Sine 30t is minus 0.6. So there is no way that the angle will be in the first 2 quadrants. It has to be only in the third or in the fourth. And therefore, mark these 2 angles as, no need of writing minus, just write 36.87 and 36.87. Okay, so this point is 0. Then when we go one full round, it is 360, and one more full round, it's going to be 720. So we need to go 2 circles around this point to hunt for all the times that are possible. But the question was saying, what is the earliest time that the boat can leave? So let's look for the earliest time. So what did we say here? 30t is equal to minus 36.87. All right. Okay. So which means if I remove this minus 36.7 from the calculation here, starting from 0, 180 plus 36.87 is equal to 216.87. 216.87 is the first one. The second one is 360 minus 36.87, and the next one will be, this is 540, right? 540 plus 36.87 is 576.87. Okay, let's stop there and we will go further if required. Okay. So let's analyze what is the second value. The first value is 216.87. No change there. This is equal to, putting into the calculator, 323.13, and the third one is 576.87. Okay, so in order to find t now, we need to divide each of these values by 30. So 216.87 divided by 30, that gives me 7.229. And the second t is 323.13 division 30, that gives 10.771. Okay, so it would appear the earliest time that the boat can leave is 7.229 hours after midnight, but then there is a catch. The question was saying the boat requires minimum 2 hours to load. So this is not possible. So we need to write not possible because the boat has ended at 6:30 a.m., right? The boat requires 2 hours after 6:30 a.m. to do the loading. So that's out. So we can circle that out. So that means the earliest time is 10.771. So that is actually 10 hours. And if you put 0.77 times 60 in the calculator, that will give 46 minutes. So 10 hours 46 minutes after midnight is going to be 10:46 a.m. There you go. Question 9. Figure 4 shows a sketch of the curve with equation x square minus 2xy plus 3y square is equal to 50. Show that dy by dx is equal to y minus x over 3y minus x. Okay, so looking at this equation, you can see this is not one which can be rearranged to make y the subject. Therefore, in order to differentiate this, we need to do implicit differentiation, which means we will go along differentiating each term, whatever comes along. And if at all there is a y coming along, we need to differentiate y and also write dy by dx. That's it. So let's write the equation first. It is x squared minus 2xy plus 3y squared is equal to 50. Okay, so now we need to write differentiating implicitly, then only it will be mathematically correct. Differentiating implicitly with respect to x. Okay, so what do we get here? 2x minus, now this term 2xy contains this coefficient 2, keep it out, and this xy is to be differentiated using the product rule. So uv dash, that is x times y dash, is 1 with a dy by dx. Okay, then plus vu dash, that is y times 1, close the bracket, and then we have got the remaining part. What is that? Plus 3 times y squared, so 6y dy by dx, because it's differentiating y, is equal to 0. Simplifying this, 2x minus 2x dy by dx minus 2 times plus y minus 2y plus 6y dy by dx is equal to 0. So there are two terms containing dy by dx on the left hand side. So let's factorize out dy by dx. Bracket, this is minus 2x and then this is plus 6y. Okay, and then let's bring out all the other terms to the other side. There is a minus 2x, there is a plus 2y. That's it. Therefore, making dy by dx the subject, we have minus 2x plus 2y all over minus 2x plus 6y. Okay, so now all the terms contain 2. So I can divide every term by 2. That is equal to minus x plus y over minus x plus 3y. And this is what the question wants is. So let's write y minus x over 3y minus x. That's it. Next part of the question, the curve is used to model the shape of a cycle track with both x and y measured in kilometers. The points P and Q represent points that are furthest west and furthest east of the origin O as shown in the figure. Using this part A, find the exact coordinates of the point P. So there is an interesting aspect here. Furthest west means it's a turning point. But the only thing is, at this turning point, the tangent is not parallel to the x-axis, it's perpendicular to the x-axis. This turning point containing the tangent is parallel to the y-axis. So at such points, it's not dy by dx is equal to 0, it is dx by dy is equal to 0. So we can write here at point P, which is the furthest west to the origin, it's a turning point indeed. We can say dx over dy is equal to 0. So what is the expression that we had got here, dy by dx? We can write dy by dx is equal to y minus x over 3y minus x, wasn't it? So now if we flip this over, we will be getting dx over dy. So therefore 3y minus x over y minus x is equal to 0. Now for any fraction in the world which is equal to 0, the numerator is equal to 0 no matter what the denominator is. Therefore we can say 3y minus x is equal to 0. Therefore 3y is equal to x. So the question wants us to find the coordinates of point P. That means x as well as y. There are two unknowns, so one equation is not enough for us. So let's write this as equation 1. We can use the equation of the curve, the original one, as the second equation because it has got x as well as y. So let's write that as x square minus 2xy plus 3y square is equal to 50 as equation 2. So if I plug in 3y is equal to x into this, so I'll be able to solve either y or x. Okay? So let's write, instead of x square, 3y square minus 3y times y plus 3y square is equal to 50. This is 9y square minus 2 times 3, 6y square plus another 3y square is equal to 50. So this is 9 minus 6, 3, 3 plus 3, 6. So 6y square is equal to 50. So from this we can say y square is equal to 50 over 6, leading to y is equal to plus or minus square root of 50 over 6. So we can write this as y equals plus or minus, dividing both numerator and denominator by 2, 25 over 3. Okay, so how do we settle for plus or minus? Looking at the diagram, we know that this cycle track is like this, and we are talking about this point. Okay, and the coordinates were like this, right? So this point is definitely going to be minus x as well as minus y. It's negative coordinates for both x and y. Hence we can say that y is equal to minus square root of 25 over 3. Now we only need to find out the corresponding value of x. So we already know the relationship between y and x here. 3y is equal to x. So x is equal to 3 times y, which means I put minus times 3 square root of 25 over 3, which is equal to x is equal to minus 3 times 5 over square root of 3, okay, which can be simplified as minus 5. You see the root 3 goes into 3 root 3 times. So we can say 5 root 3 here. Simplifying this y value, this is equal to minus the square root of 25 can be written as 5 over square root of 3. So we can rationalize this denominator here. Therefore, y equals minus 5 root 3 over 3. So hence, P is x coordinate is minus 5 root 3, y coordinate is minus 5 root 3 over 3. So it is mathematically correct to write like this. C part. Explain briefly how to find the coordinates of the point that is furthest north of the origin O. You do not need to carry out this calculation. So you just need to explain how you will be getting it. It's a 1 mark question. So here it's furthest north. Furthest north of the origin is a turning point which is parallel to the x-axis. So it is dy by dx is equal to 0. So we could actually write, see here, if you can see the diagram, you'll be understanding it. Furthest north is somewhere here. So this is the turning point. If you draw a tangent, that's going to be parallel to the x-axis. Therefore, at that point, dy by dx is equal to 0. So similar to what we did for point P, instead of dx by dy, we can do dy by dx is equal to 0, and we can solve for the coordinates using the two equations. So how we can write it here is, at northmost point of the origin, of course, northmost point, comma, it's a turning point, okay, maximum or minimum, it must be maximum, where dy by dx is equal to 0. So hence, by setting dy by dx is equal to 0 and using the original equation of the curve, so there are two equations now, equations 1 and 2. So we will be able to sort out x as well as y. We can solve for x and y coordinates. It's a 1 mark question, but we need to explain clearly how we will be able to go about it. Question 10. The height above ground, h meters, of a passenger on a roller coaster can be modeled by the differential equation dh by dt is equal to h cos 0.25 t over 40, where t is the time in seconds from the start of the ride. Given that the passenger is 5 meters above the ground at the start of the ride, this information is useful for solving out the k. Show that h equals 5 e to the power of 0.1 sine 0.25 t. So this is a classic differential equation question. So what we need to do is rearrange it so that we have only dh on one side and all the h terms on that side, and dt on the other side along with all the t terms on the other side. So let's write the equation here. So a dh by dt is equal to h cos 0.25 t all over 40. Right. Identify the terms that we have to interchange. You've got an h here on the right and there is t there. So dt obviously has to come to the numerator. So what we will do is we will put 1 over h on the left and then dh is equal to cos 0.25 t over 40 and then dt. So immediately after we write dh and dt, we need to put integral signs, because without the integral sign, dh and dt do not have any existence. Okay, now we need to integrate both sides. Okay, both are integratable expressions. So we can write here ln h is equal to, what about integration of cos 0.25 t? This 40 in the denominator is a coefficient, so there is no change to it. So we can say 1 over 40 times cos integrates to sine. So sine 0.25 t. Then we also need to account for this 0.25 t. When we differentiate, we multiply by this. When we integrate, we need to divide by it. So 0.25 in the denominator. So that is ln h is equal to 1 over 40 times 1 over 0.25 is, there is also a plus k we need to write here. Okay, so when we integrate, there will be a constant on the left and a constant on the right, but we can accumulate all the constants to the right with one single k. Right, so ln h is equal to 1 over 40 times 1 over 0.25 is 1 over 10 sine 0.25 t plus k. Okay, so in order to solve for k, we have been given additional information in this question. That is, at the start, that is t is equal to 0, h was equal to 5. Okay, so we can plug that in here. So when h is 5, t is equal to 0, 1 over 10 sine 0.25 times 0 plus k. Right, that is ln 5 is equal to, this whole term becomes a 0 because sine 0 is 0. So 0 plus k, so k. So we got ln 5 is equal to k. Therefore, we can now use this equation to write out ln h is equal to 1/10 sine 0.25 t plus ln 5. So not over, we need to get h on one side all by itself. Then only our calculation will be completed. So we need to bring in, let's bring in the lns to one side. Ln h minus ln 5 is equal to 1/10 of sine 0.25 t. Okay, so this is ln h over 5 using the division rule for logarithm is equal to 1/10 sine 0.25 t. Okay, so what is the next step? You know that ln has got a base e here. So whenever we have, remember, 100 is equal to 10 square can be written as log 100 to the base 10 is equal to 2. So we can use the same principle here. There is a e hiding here. So we can write, kicking off the ln, h over 5 is equal to e to the power of all these things. 1/10 sine 0.25 t. Alright, therefore h is equal to, multiplying both sides by 5, we have 5 e to the power of 1/10 sine 0.25 t. So is that what the question wanted us to write? Let's have a quick look. H is equal to 5 e to the power of 0.1 sine 0.25 t. So we can replace this 1/10 as 0.1. That's it. Part B. State the maximum height of the passenger above the ground. So we need to figure out what is h max from this equation. So part B, we can say h max is equal to 5 e to the power of 0.1, and then pause there. This sine 0.25 t is sine of an angle. Sine of an angle is always oscillating between what? Greater than or equal to -1 and less than or equal to +1. Therefore, if you are looking for height maximum, you should have sine 0.25 t equal to 1. Therefore, this is equal to 0.1 times 1, which will give you 5 e to the power of 0.1, which we put into the calculator and we get 5.53 meters. Part C. The passenger reaches the maximum height for the second time t seconds after the start of the ride. Find the value of t. So here we have to solve for t using that equation. So in such questions where the question does not tell you whether to use degrees or radians, and if the question is talking about time, hours, seconds, etc., it's better to go for radians. So let's write the equation for the height once again. height is equal to 5 e to the power of 0.1 sine of 0.25 times t, isn't it? Okay. So this sine is oscillating. Therefore, if I draw this sine curve, the question is asking for the second time when he reaches the maximum height. So the first time he will be reaching the maximum height when 0.25 t is equal to, see, sine of the angle should be equal to 1. Therefore, 0.25 t should be equal to pi over 2 for the first time, because it will be at 1 here. Then next time this is going to be pi, it's going to become 0. This is 3 pi over 2. Okay, it will be negative here, and then here it's 2 pi, it will be 0 again, and then once again it will come up when it is 2 pi plus pi over 2, which is 5 pi over 2. If you are drawing this, okay, wait, yes, drawing the sine curve, right, not cos. So this one here, and then from here negative, and then 0 again, and then going to the top equal to 1 here once again. So at 5 pi over 2. So first one is at pi over 2. Second one is at 5 pi over 2. This 0.25 t will be equal to 5 pi over 2 to make sine of this angle equal to 1. So we need to write t is equal to 1 over 0.25 times 5 pi over 2. This is equal to, we can write this 0.25 as 1/4 in the denominator times 5 pi over 2. And this 1/4 flips over, so it will become 4 times 5 pi, 20 pi over 2, and that is equal to 10 pi. That means at 10 pi seconds, that is capital T, which is mentioned in the question, is 10 pi seconds, which is equal to 31.4 seconds otherwise. Question 11. Use binomial expansions to show that square root of 1 plus 4x over 1 minus x equals 1 plus 5 over 2 x minus 5 over 8 x square. So we only need 3 terms right up to the value of x square. Okay, so you can see that there are 2 binomial expansions going on here, one in the numerator, one in the denominator. Okay, so we need to expand this. There are 6 marks for this question. So let's write out this expression. It's going to be square root of, in the numerator, 1 plus 4x over, in the denominator, 1 minus x. Okay, this can be written as 1 plus 4x to the power of half times 1 minus x to the power of minus half, because this is also square root but appearing in the denominator. So you can see here there are 2 binomial expansion formulae going on here. So in both cases it's fraction as well as negative. Hence our binomial expansion which you learned in year 1 will not apply here, because n is not a positive integer. Therefore we need to use the second year binomial expansion formula, which is of this type. 1 plus x to the power of n is equal to 1 plus nx plus n times n minus 1 x squared times 1 over factorial 2 plus n times n minus 1 times n minus 2 times x to the power of 3 times 1 over factorial 3, and so on. So we only need the first 3 terms here, but we need both these expansions to be done for 3 terms. So let's start one by one. It's better to do them separately. So 1 plus 4x to the power of half is equal to 1 plus nx. So half times 4x plus n times n minus 1. So half times minus half times 4x to the power of 2 times 1 over factorial 2 plus dot dot. So now let's simplify this. This is equal to 1 plus half of 4x is 2x. Okay, so this is going to be plus times minus is minus. Then 1 over 2 is 1 over 4. And then this is another 1 over 2. So it's going to be 1 over 8 times 16x square plus dot dot dot. That will simplify to 1 plus 2x minus 8 goes into this 2 times, so 2x square, okay, plus dot dot dot. So let's park it there. This is equation 1. The second part is 1 minus x to the power of minus half. That will be expanding to 1 plus nx, that is minus half times minus x. Remember to put minus x here. Okay. Then plus n times minus half times n minus 1 is going to be minus 3 over 2 times minus x to the power of 2 times 1 over factorial 2 plus dot dot dot. Simplifying this, we get 1 plus x over 2 minus times minus is plus, and this is also plus, so this will end up as plus. So 3 over 4 and another 2 here, so 3 over 8, and this is x square plus dot dot dot. So that is equation 2. Therefore 1 plus 4x to the power of half times 1 minus x to the power of minus half is equal to, we need to multiply these two groups of expressions. So 1 plus 2x minus 2x square plus dot 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 times 1 plus x over 2 plus 3 over 8 x square plus dot dot dot. For simplifying, we need to multiply 1 with every term in the second. So 1 plus x over 2 plus 3 over 8 x square plus 2x times 1 is 2x plus 2x times 3 over 8 x square is going to be 3 times 2, 6. 6 over 8 x to the power of 3. Okay, that's done. So we have come up to that much. Now we have to multiply by 2x square. 2x square times 1 is minus 2x square here. Then minus 2 and 2 will cancel. X square times x is x cubed. That's right. Then the last one is minus 2x square times, we don't need that because it's x to the power of 4. So let's write plus dot dot dot. So we need to only need up to x square. Even x cubed is not required. So now let's simplify. So what terms do we have? So 1, there is no other constant. So 1. Okay. Plus there is an x over 2. There is a 2x. And there is no other x term. So x over 2 plus 2x will be 4x plus 1x, 5x over 2 plus. Now let's add the x square terms. 3 over 8 x square minus 2x square. So 3 over 8 x square minus 2x square. Right? That means 8 times 2 is 16. So minus 16 plus 3 is 15 over 8 x square. Is there any other x square term here? So 3 over 8 x square minus 2x square. There is one more term in the multiplication, 2x times x over 2. That is 2x times x over 2 is x square. So we need to plug in that x square here. Then 2x times 3 over 8 is 6 over 8 x cubed and so on. So we need to add all these x square terms. So 3 over 8 x square minus 2x square plus 1 more x square is equal to, putting into the calculator I get minus 5x square over 8. Okay, so let me write that here, minus 5x square over 8. and then we put plus dot dot dot. So 1 plus 5x over 2 minus 5x square over 8. So that's the answer for that question. Part B, give a reason why the student should not be using x is equal to half. So this is concerning the validity for convergence of series. So you know that when we expand it, the modulus of the second part in the expression should be less than 1. So here we had two binomial expansions going on. So first one was 1 plus 4x to the power of half, right? And the second one was 1 minus x to the power of minus half. Okay, so this expansion is valid only if modulus of 4x is less than 1, which means modulus of x is less than 1/4. Okay, in the second one, this is valid only if modulus of minus x is less than 1, which is modulus of x is less than 1. So we have two conditions here, and we need to go for the more strict condition of the two. So let's draw the number line. Okay, suppose this is 0 here, and this is 1/4, and this is 1 approximately. Okay, so this, as per this second condition, modulus of x should be less than 1. Okay, and as per the first condition, modulus of x should be less than 1/4. So I'll draw here, right? So even though the first one says less than 1, the second one restricts it from 1/4 and lower than that. That means I can't do anything more than 1/4. And now our half lies somewhere here, and therefore it's outside the range. So that's what we need to write here, as half is outside the validity range. So how will we express that? We can say modulus of x should be less than 1/4. So if it is 1/2, it is not less than 1/4, it's more than that. So as half is outside the validity range, x is equal to half is not a valid input. Hope that is clear to you. Part C, substitute x is equal to 1 over 11 into this expansion to obtain an approximation to square root of 6. Give your answer as a fraction in its simplest form. So what we need to do here is, if we put x is equal to 1 over 11 in this expression on the left hand side, we should be able to manipulate it and get square root of 6 all by itself on one side, and then we can multiply the right hand side by the required constant from the left, and thereby we will be able to get the value of square root of 6. So before we do anything, let's write out the expression once again. So C, square root of 1 plus 4x in the numerator and 1 minus x in the denominator. So let's put x is equal to 1 over 11. Okay, so that is square root of 1 plus 4 over 11 divided by square root of 1 minus 1 over 11. That simplifies to 11 times 1 plus 4 is square root of 15 over 11 divided by square root of 11 minus 1, 10 over 11. So basically it is going to be square root of 15 over 10. So how to get square root of 6 from here? We can rearrange this. Make 15 times 2 is 30. So we can write 30 over 2 times 10 is 20. And that will give us square root of 5 goes into 30 6 times, and 5 goes into 20 4 times. Okay, that is equal to square root of 6 over 2. Brilliant. That means the left hand side is square root of 6 over 2. Hence, what we could do is keep square root of 6 here and put 2 and do the expansion on the right hand side. So the right hand side expansion is what? 1 plus 5x over 2. 1 plus 5 over 2. Then we will be writing 1 over 11 because x has to be replaced with 1 over 11. Right? And then minus 5x square over 8. Minus 5 over 8 times 1 over 11 square. Simplifying this, square root of 6 is equal to 2 times 1, 2. 2 times 5 over 2 is 5. That is 5 over 11 minus 2 times 5 over 8 is 5 over 5 over 4 times 1 over 11 square is 121. All right. So putting this into the calculator, the right hand side, that gives us 1183 over 484 as the simplest fraction. Question 12. The value V pounds of a vintage car 2 years after it was first valued on 1st January 2001 is modeled by the equation V is equal to A P to the power of T, where A and P are constants. Given that the value of the car was £32,000 on 1st January 2005 and £50,000 on 1st January 2012, find P to 4 decimal places and show that A is approximately 24,800. So let's write the exponential equation here. V, the value, is equal to A times P to the power of T. And it's also given that the first valuation was done on 1st January 2001. In 2005, the value became 32,000. And in 2012, the value was £50,000. And we need to find out the value of P and value of A. So these two equations are good enough for us to do that. What we will do here is, we will put in these values. Instead of V, we will put 32,000 is equal to A P to the power of T will be what? 2005 means it's 4 years after 2001, so 4. Similarly, 50,000 is equal to A P to the power of, this is 2012, so 11 years after 2001. So this one, let's say this is equation 1, this is equation 2. So the greater one is the equation 2. Let's do one thing. Divide equation 2 by equation 1. So that will give us 50,000 over 32,000 is equal to A P to the power of 11 over A P to the power of 4. Cancelling out these three zeros, A and the A, and then we will be getting 50 over 32 is equal to P to the power of 11 minus 4 is 7. From here, we can find out P by taking the 7th root of 50 over 32. So how do we write that? Put that in a bracket and put 1 over 7. Putting that into the calculator, I get 1.0658 to 4 dp. Okay, part 2. So let's put one of these two equations with the P plugged in, and then we will be able to find out the value of A. So 32,000 is equal to A bracket 1.0658 to the power of 4. Right? From here, we need to write A therefore is equal to 32,000 division 1.0658 to the power of 4. Again, putting this into the calculator, I get 24,796, which approximates to 24,800. So that's what we had to show as per the question. Part B. With reference to the model, interpret the value of the constant A and the value of the constant P. So we need to interpret it. So let's write the equations once again. So B part I. So we know that V is equal to A 1.0658 to the power of T, right? And A is also equal to 24,800 times 1.0658 to the power of T. So when T is equal to 0, V becomes equal to 24,800. So we can very safely say here that A was 24,800, the value of the car as on 1st January 2001. Okay. Therefore, A is the value of the car as on 1st January 2001 when it was valued for the first time. For the P value, P is equal to 1.0658 is the factor by which the value increases each year. Is the factor by which the value of the car increases each year. Fine. Using the model, find the year during which the value of the car first exceeds 100,000 pounds. So let's write 100,000 pounds in place of V, that is equal to 24,800 bracket 1.0658 to the power of T. Now we need to solve for T here, which is the only unknown here. Therefore, we will be finding out the year in which the value becomes 100,000. So rearranging, we will get 100,000 upon 24,800 is equal to 1.0658 to the power of T. Therefore, if we take logarithm, we will be able to find the value of T here. So we can write log bracket 100,000 upon 24,800. Now bring this 1.0658 as the base here, 1.0658, and that will be equal to the value of T. And when I put this into the calculator, I get 21.8 years. The question is asking us, during which year will the value become 100,000? So 21.8th year from 2001 is going to be year 2022. Question 13. Show that integral between 0 and 2 of 2x square root of x plus 2 dx is equal to 32 over 15, 2 plus root 2. So this is an example of integration by substitution. So let's write, let u be equal to x plus 2. So when we use integration by substitution, remember, we need to get rid of every bit of x, including dx, and we should bring in terms in u. And we also need to reassign the values of the limits here, because this 0 and 2 are referring to the values of x. We need to change them to the values in u, corresponding values. So first let's rewrite the entire expression in u. So x plus 2 is equal to u. Therefore, this part is u to the power of half. Okay, and then we need to rewrite 2x. Therefore, u minus 2 is equal to x, and therefore 2 bracket u minus 2 is equal to 2x. So this is 2 bracket u minus 2. Right. Now we need to find out what value of u will be equal to dx? For that, let's differentiate u is equal to x plus 2 with respect to x. So we write here du by dx is equal to 1, which means du is equal to dx. So very safe here. So we just write dx is equal to du. All that now remains is we need to change the limits. So let's put two columns. Okay, let's put x here and u here. When x is equal to 0, what's u? When x is equal to 2, what's u? Let's figure out. So we know that u is equal to x plus 2. So when x is equal to 0, u is equal to 2. Okay. When x is equal to 2, u is equal to 4. Therefore, we can now rewrite this entire integral expression as between 2 and 4 of 2 bracket u minus 2 bracket u to the power of half du. Let's simplify this before we start actual integration. So this is equal to between 2 and 4, 2u minus 4 times u to the power of half du, which is equal to integral between 2 and 4 with 2u to the power of 1 plus half is 3 over 2 minus 4u to the power of half du. This is ready for integration now. Therefore, let's start with a square bracket. Okay. So 2 is a coefficient, no change there. U to the power of 3 over 2 add 1 divided by 3 over 2 add 1 minus 4u half to the power half plus 1 is equal to 3 over 2. Then I have to divide by 3 over 2, which is equivalent to multiplying by 2 over 3. Okay, and then put the limits here 2 and 4. This simplifies to 2 times u to the power of 5 over 2 times 2 over 5 minus 4 times 2 is 8, 8 over 3 u to the power of 3 over 2 and then square bracket once again between 2 and 4. This is again equal to 2 times 2, 4 over 5 u to the power of 5 over 2 minus 8 over 3 u to the power of 3 over 2 between 2 and 4. Now this can be easily evaluated. So we will start putting smaller brackets here now. So 4 over 5 u becomes 4. So 4 to the power of 5 over 2 is square root of 4 to the power of 5, which is 2 to the power of 5, which is 32. Okay, minus 8 over 3, u is again 4, square rooted is 2, 2 to the power of 3 is 8. Okay, bracket minus, now let's put all the values of u as 2. So 4 over 5 square root of 2 to the power of 5 minus 8 over 3 square root of 2 to the power of 3. Simplifying this, we get 4 times 32 is 128 over 5 minus 64 over 3 minus, this is 4 times square root of 2 to the power of 5. Square root of 2 to the power of 5 is 4 root 2. That means 16 root 2 over 5. Then minus times minus is plus 8 over 3 times root 2 to the power of 3. Root 2 to the power of 3 is 2 root 2. Therefore, it is 16 root 2 over 3. Putting the first 2 into the calculator, we get 64 over 15. Putting the third and the fourth terms into the calculator, I get plus 32 square root of 2 over 5. This can be simplified further to what the question wants us to write. you can see that 32 over, this is 32 root 2 over 15. Okay, so 32 over 15 is common in both, so we can factorize it out. That is equal to 32 over 15. Inside bracket, what remains here is 2 plus square root of 2. There you go. This is what the question wanted us to manipulate to show as the result. Question 14. A curve C has parametric equations x is equal to 3 plus 2 sine t and y is equal to 4 plus 2 cos 2t, where t is between 0 and 2 pi and t being equal to or greater than 0. Show that all points on C satisfy y equals 6 minus x minus 3 square. So this is a classic case of parametric equations requiring you to convert that into Cartesian equation, because y equals 6 minus x minus 3 square is a Cartesian equation. So what's the strategy in such cases? We need to make t the subject from the x parametric and plug that into y, so we will get a Cartesian equation. But in some cases, like in this case, where trigonometric ratios are involved, it might be better to make sine t the subject. So let's write the parametric equations first. X is equal to 3 plus 2 sine t and y equals 4 plus 2 cos 2t. Trying to make sine t the subject here, we can say x minus 3 divided by 2 is equal to sine t. Now if I can make y equal to in terms of sine t, that will be a success for us. Then we can replace the sine t there with x minus 3 over 2, and that will become the Cartesian equation. So trying to sort this out, we can say y is equal to 4 plus 2 bracket. Cos 2t can be expanded using the double angle expansion formula, that is cos square t minus sine square t, which simplifies to, let's remove this cos square t and put it in terms of sine square t. So y equals 4 plus 2 bracket 1 minus sine square t minus another sine square t, which will be y equals 4 plus 2 minus 2 times sine square t minus 2 times sine square t. That is y equals 6 minus 4 sine square t. Now if I plug this value of x minus 3 over 2 in place of sine t here, I will be getting y equals 6 minus 4 bracket x minus 3 over 2 whole to the power of 2. So that will simplify to y is equal to 6 minus 4. Let me keep this x minus 3 whole square as it is, but square the denominator of 2 into 4, which means this 4 and this 4 will cancel, and we have 6 minus x minus 3 square. There you are. Part B. Sketch the curve C and also explain briefly why C does not include all points of y equals 6 minus x minus 3 square, where x belongs to the set of real numbers. Now the strategy for sketching out any curve is first determine the general shape of the curve. Second, the domain of x. Domain, the range of y. Okay, any turning points, any roots, etc. These are the things that we need to draw any curve. So going by this, let's first of all see what kind of curve is this y equals 6 minus x minus 3 whole square. So if I draw a sketch here, then it will be quite helpful to find the general shape of the curve. This is actually a derivative from y is equal to x square. It has been transformed into this. So let's imagine the original curve was y is equal to x square, which is a square curve. Okay, this is y is equal to x square. Any part on the right hand side of y and any part on the left hand side of y, if you square them, you'll get the same value of y. Right. Now, imagine that we are going to transform it into x minus 3 square. That means y becomes x minus 3 square, which means it should move to the right by 3 units. So let's say it moves here 3 units. So this will become what? 3, 0. Perfect. Now next transformation is put this minus here. Therefore y is equal to minus x minus 3 square will mean a reflection in the x-axis of this y is equal to x minus 3 curve, isn't it? This is y equals x minus 3 square. It's going to be reflected now in the x-axis to get this curve now. So this is y equals minus x minus 3 square. Perfect. Now the next and last transformation is you need to give to the effect of putting an x plus here. That means it is affecting the y values. The whole curve is going to be pushed up by 6 units. Therefore, let me draw that in red. Okay. It will go up by 6 units means this is currently at 3, 0, this turning point. It will now become a turning point here. With what? This will be 3, 6. Right? So let me remove all the other parts of the curve. These are all gone. So this is going to be the general shape of the new curve y equal to 6 minus x minus 3 whole square. But it will not hold good for all the terms of x and y because the question has restricted the domain as well as the range. Therefore, going by the general shape, and if we have also the maximum of x and y, then we will be able to conclude on the shape. So in order to find what is the domain of x, let's say x minimum, x maximum, y minimum, y maximum. So we will be able to sketch the graph correctly. What is the curve for, what is the equation for x? X is equal to 3 plus 2 sine t. And t also belongs to the range, domain 0 to less than 2 pi. And y equals 4 plus 2 cos 2t. Cool. Now if you put any value of t here, sine can only oscillate between, let's say sine t is always greater than or equal to -1 and less than or equal to +1. Therefore, x maximum will be when it is 3 plus 2 times 1. So it is equal to 5. X minimum will be when sine t is minimum -1. Therefore, it is 3 plus, which will become 3 minus 2 because 2 times -1. Okay, so I can put plus 2 bracket -1, which is equal to 3 minus 2, which is equal to 1. Right. Similarly, let's find the range for y. So maximum value for y will be y is equal to, let's write here, 4 plus 2 times cos 2t or cos 100t doesn't matter. Its maximum value will be +1 and minimum value will be -1. Therefore, if it is maximum, it's going to be +1 here. So 4 plus 2 is 6. Similarly, the minimum will be 4 plus 2 bracket -1 is equal to 2. So we have all the required information: x minimum, x maximum, y minimum, y maximum. So in this rough sketch of the curve, if I can put those maximum and minimum, we will be able to get the final curve. Okay, so x maximum was what? 5. So let's put 5 here. X minimum was what? 1 here. Okay, it actually nicely gets the midpoint. If you add 1 plus 5, 6 divided by 2, that is correctly at the top of the parabola here. Next, y value was minimum 2 and maximum 6. That means if I combine all these restrictions, the curve should be starting from here and should be ending here. Therefore, this part and this part we can safely delete. Therefore, to sketch the curve now as a final correct sketching for answering the question, let's put this as 0, 0, x-axis, y-axis, put this as 6 here, put this as 2 here, 1 here, and 5 here. Okay, start from here, end here, the top will be here. That's quite easy now. Right, it's only a sketching, it's not drawing, so we only need to be accurate to a certain limit. Okay, so let's mark this point as 3, 6. This point is going to be 1, 2. This point is going to be 5, 2. Perfect. In the same part of the question, we were asked to explain why C cannot take all the values of X in the real group or real set. So we already know C cannot take all the values of X because of these restrictions. So we can say C cannot take all values. Cannot take all values means it will not be valid for all values of X in the real set. It's called this because X is equal to 3 plus 2 sine t, with t being greater than or equal to 0 and less than 2 pi, and hence X is greater than or equal to 1 and less than or equal to 5. That should explain correctly why X cannot be from a real set of R for all values in C. Last part of the question, the line with equation x plus y equals k, where k is a constant, intersects C at 2 distinct points. State the range of values of k, writing your answer in a set notation. That's 5 marks. Okay, remember x plus y is equal to k is a new line, and we have got the original curve there. So they are going to intersect at 2 distinct points. So let me write the 2 equations that are in reference. So y is equal to k minus x, because y plus x is equal to k. So y equal to k minus x is one equation. Second equation is y is equal to 6 minus x minus 3 whole square. This is the second equation, which is for the curve that we have found out. Now you can see that y is equal to k minus x is a derivative of y is equal to x. So to put that into perspective in a sketch, it will be quite clear to understand what we need to do. So our original curve was something like this, where this is 1, this is 5, this is 2, and this is 6. Okay. What is y is equal to x curve? Let me draw that in red. So we have y is equal to x. That is this line. If it is y is equal to minus x, it's going to be the opposite of it. It's going to go down with a negative 1 as the gradient. Okay. So that is y is equal to minus x. Now if I put y is equal to k minus x, that means I'm going to add a value of k to the y. That means it will either push it up or push this down. So all these lines are y is equal to k minus x. Okay. Now the question puts a catch. It says that y is equal to k minus x cuts the curve C at two distinct points. Which means what? Which means these lines are out because they will not cut this curve at all. Now, if I have a line here, that's also out of question because it's not going to cut it at two places. The moment it actually goes through this point, that is, this point is what? 5, 2. That's when it is going to cut the curve at two distinct points. Okay, so going further, K can go further up, because this is going to be the y-intercept. Y-intercept is going to be 0k here, right? Now, this k can increase, and finally, at the last point where it touches here, it's going to be a tangent, and that will be excluded because it will be only touching the curve at one point. We need to get below that particular point so that the line will be cutting the curve at two distinct places. So our strategy should be put the two equations, that is equation for the line as well as equation for the curve, against each other and solve for x and y. Okay, so let's write y is equal to k minus x and y is equal to 6 minus x minus 3 whole square, and put at intersection point they should be equal. So k minus x is equal to 6 minus x minus 3 square. Going further, this is k minus x is equal to 6 minus, let's expand this out, put a bracket because this minus will play havoc, x square minus 6x plus 9. Okay, simplifying this, k minus x equals 6 minus x square plus 6x minus 9. Right, so bringing them all into one side, we can say x square to make it a quadratic. Okay, 6x and minus x here makes minus 7x. Minus 9 plus 6 is minus 3 over there, so it will be plus 3, and this k is also here, is equal to 0. So let me put this as a bracket. So this is going to be, a is a quadratic with ax square plus bx plus c format. Therefore, a is equal to 1, b is equal to minus 7, c is equal to 3 plus k. Yes, there are two intersection points. Therefore, the determinant should be greater than 0. It should be positive. So b square minus 4ac should be greater than 0. Therefore, let's plug in the values from here. So minus 7 square minus 4 bracket a is 1 bracket c is 3 plus k should be greater than 0. That means minus 7 square is 49 minus 4 times 3, 12 minus 4k is greater than 0. Simplifying this, this is 37 minus 4k should be greater than 0. That means 37 should be greater than 4k, leading to k should be less than 37 over 4. So k is equal to less than 37 over 4 is telling you about the maximum value here. So what will be the minimum value when this line goes to this point 5, 2? Then it will be cutting the curve at two distinct points, right? So let's put equation y is equal to k minus x at 5, 2. So let's put at 5, 2, okay, y is equal to k minus x. Y will be 2, k minus 5, which will give us a value of k is equal to 5 plus 2, 7. Right. So k should be equal to and greater than 7 and less than 37 over 4. That gives us the range of values. So k should be greater than or equal to 7 and less than 37 over 4. Okay. So in order to put this in the set notation, what we do is start that wiggly bracket, double bracket, and then put k, put two dots like this and put an arrow, okay, and then put this here inside a bracket and complete it. So that's it. That's the last part of the question. So going by the length of this video, you can see that there are a few more minutes for completion of the 2 hours. So in the exam situation, you can use the time to go back and check if everything is in order. I will strongly recommend candidates and students to go over this question paper, the walkthrough and the methods, and then take a fresh printout and then set your stopwatch and start at a time which is quite comfortable to you in the morning, afternoon, or evening, and try to finish it within 2 hours and compare your results with the actual answers, and then decide for yourself where you are. To get a star in the A-level exam, you should be able to finish within the time as well as get a high degree of accuracy. So hope this walkthrough has been quite useful to you. Till the next time when we meet in another episode of the walkthroughs. Thank you.